Hello everyone, I've made a template for getting going with hot reload for the Sokol libraries in the Odin programming language. Sokol is, among other things, a library for sort of abstracting away the rendering API, so you can write some code that can run on different platforms and be translated into OpenGL or Direct3D or Metal and stuff like that. So I have some, I'm going to show first sort of just a little demo of the hot reload, and then we'll look at how to set it up and all that stuff. So here in Sublime Text, I can press F7 in this template to sort of compile and run the game. And the template looks like this. This is essentially the Sokol sample, the cube Sokol sample, but I've added textures on the side. And I can go back to my code here. We see that it's sort of like it did some stuff where it built some shaders, it built some DLL, and started some game hot reload exe down here. We can go here and, for example, select this here. So this cube is spinning right. These numbers control how fast it spins in the X direction and in the, or around the X axis and around the Y axis. If we increase this to 500 and I press F7 to again, then you see that this just started spinning a lot quicker. And what happened here, if you look in the log down here, is that it rebuilt some DLL and then it says hot reloading. And you can play around like this and recompile the gameplay code while the game is running. This is similar to what I've done before in Raylib, but now this is possible with Sokol as well. The primary use case of this is to tweak gameplay code, maybe tweak the behavior of procedures as the game is running. Maybe you have some gameplay code that has to control some ability of a character that you want to test many different variations, or maybe you're tweaking how your UI is laid out and you're pushing things back and forth. It's super for all that. There are some limitations to this. For example, if you change struct layouts while the game is running, like you make a struct bigger, then it might not work that well. So let's look at how to set this stuff up. And then after that, I can go a bit into sort of how it works also. So to use this stuff, you can go to this GitHub page, which is linked in the description. This is the repository. You can clone that. So when you've cloned the repository, you will have something like this on your computer. We see here that there is some build Python file, and then there is a source folder with some Odin code inside and some different folders and all that. What we need to do now is to run this build Python file. So this file is a script that can download Sokol, compile Sokol, compile sort of the hot reload executable and the hot reload DLL and all that stuff. It can also do a release build and also a web build using mscripten. In order to use this one to sort of install Sokol, because Sokol also needs to sort of compile the C libraries that it needs, you will need to run this script from a command prompt that has access to a C compiler. So on Windows, you would do that by opening the x64 native tool command prompt. On many systems, like some Linux systems, you might have a compiler inside the path, so it's available everywhere already. So now I've navigated to the folder where I put the template, and I can run build.py-update Sokol like this. So what this will do now, it will download the bindings, the Odin bindings for Sokol, and the shader compiler that Sokol needs, and then it will tell it to compile the C libraries of Sokol, so that the Odin bindings have some binaries to some libraries to use, some code to call into. So it finished all that. It does say here at the end that EMC is not in path skipping building of wasemlibs. So we won't have web support right now. I'll show that at the end how to get the web stuff going and build the web libs. If we go back now to the file explorer here, we see that this folder has appeared. This contains the different shader compilers for different platforms. And inside the source folder here, you have a new folder called Sokol. This contains the bindings for Sokol, and it has also compiled the DLLs here, and inside these folders you have these library files that was also compiled when it ran update Sokol. if you just need to recompile, like if the update Sokol call fails on the first time because you didn't have access to a C compiler, you can also run build.py-compile Sokol like that. Not instead of update, you write compile. That will skip re-downloading it. Now that we've done all that, we can rerun build.py with -hot reload and -run. This will build the hot reload host application, as I call it, and it will be like the DLL that contains the hot reloadable code, and then when it finishes all that, it will run it. And this build process will use the Sokol bindings that were downloaded along with the C libraries that was built as part of the previous stuff we did. So we do that, and then we see this pops up just like it did at the beginning of this little video. So if we make this smaller now again, like that, now I can just show here what, because I did it in Sublime earlier, just to do a quick demo. I'll show how the flow of commands actually is here. So we have the game running here, and inside the template here, we have the source folder, and inside here we have the game.odin file. So if we open the game.odin file, then we see this stuff here again. We changed this rotation around the x-axis in the beginning of this video. Let's do something else here. We can change this clear color. This is the background color that it clears with. Then we can go back to our command prompt, and we can run the same command again. Doesn't matter, it says -run at the end. The -run will only start the host application if it's not already running, so it actually sort of ignores it if it's already running. But what we see that happened here was that it, instead of like it said up here it said building the game hot reload.exe, starting it, now it just said hot reloading instead. So it rebuilt DLL, and then the host application noticed that it changed, and it then reloaded it, so we could use that code instead. You know, we can work on stuff here, just to do other changes now. We can change this speed to 700, rerun this, and all that. This shows this stuff here shows what I did at the start of the video from within Sublime. That's just a Sublime project that comes with the template that's sort of pre-set up to do the same things as I did here. So if you look in here, there is a Sublime project file here, and that just contains a build system that does the calls to the build script, just like we did here manually. There is also a VS Code folder here if you use VS Code, and that also can do the same stuff. Let me close this now, and I'll show you some other build modes of this template. I'll undo this so we get back to how it was. So if I run build.py-release-run like this, then it makes the sort of release version of the game, right? And then with -run it will again start it. And this has no hot reloading. This is for making a native build of your game that you want to send out to people. Regardless of if you use the hot reload or if you use release, you can always add on -debug at the end. That will make it into a debuggable executable that you can send into a debugger or something. Without that, it won't have the debug symbol, so it will not be very debugger friendly. Now let's look at how the hot reload works. After we look at how the hot reload works, I will just talk a bit about how to make also a web build of your game using this template. So while you can open the build script if you want and look at what the build hot reload functions in there do, but essentially what happens is that the host application is in this folder here, main hot reload, and the game DLL is built from the stuff in here. So main hot reload is a program built from this stuff here, and if we look at what it is, it's essentially a program that sort of starts up the Sokol application, which is sort of creates the window and all that, and then it loads the game API, and the game API comes from loading the game DLL. So it has sort of this, and this is similar to the Raylib hot reload stuff I've shown before on this channel. We have a game API struct here, and these functions here are populated from whatever is available inside the DLL, the game DLL. So we see here that, for example, this init proc here will be mapped up to the game underscore init proc inside the DLL. This frame proc here will be mapped up to the game underscore frame proc in the game DLL. So inside game here, we have game frame. This procedure here is what is run when you call this one on the game API. So the host application continuously checks the last write time of the game DLL. And if it notices that it has a different write time than the one that was used to create the current game API, then it loads the new DLL and creates a game API using that one. That's what's happening here. And then down here, we do the sort of hot reload. What this does is that it asks the old game API for a pointer to the main memory blob that sort of there is inside game.odin here. If we go to the top here, there is a game memory struct here. This thing here is sort of a global pointer inside the game DLL. And what the memory proc here, the game memory, this just returns a pointer to that one. So that's what is happening here. This will call game underscore memory inside the game API, and then it sets the game API to the new game API that was loaded from the new DLL, and then it feeds that new game API the same pointer back. So that will go into game hot reloaded, which is this procedure here. And you see what this does, it just assigns this global pointer G to that pointer. So then the new DLL has all the new code, but the global variable G up here will be a pointer to the exact same memory as previously in the old DLL, and things can just continue. And this is why it works very nicely to tweak what procedures are doing and all that. But if you were to change the layout or how big this game struct is, or you move things around in it, then things might not work so well. I also have a little extra security check here. Like here it checks if the memory size is the same of the new and the old game API. And if they differ, it actually forces a restart. A forced restart is essentially that it unloads, it sort of restarts the game completely. So it sets up some new game memory blob. So it just restarts the game. It's essentially like closing the executable and opening it again without having to do that. And that's sort of a security thing. Like if you do change the layout in here, it will catch that rather than just crashing, because that's usually what would happen if it started reading the wrong thing at the wrong position in a struct. You can also manually trigger this force restart if you really want to. So if the game is running, then you can actually press F6, and that does the same thing as if the memory layout changed. It tears down the whole game and sort of starts it up again with a new memory blob. And that's nice if you want to just restart your game without having to close the exe and starting it again. So inside game.odin then, there is maybe 4 procedures that are extra interesting, that are sort of exported, that the host application will call on the game DLL. The first one is the app default description. This just tells it sort of how to set up the window a bit. This is in here rather than in the host application, because it can be reused for the release build and the web build and stuff like that. So it just says like what's the window title and some settings, some size of the window. Then the init proc here, you see this creates the initial memory blob here, and then it sets up, this is the Sokol graphics setup stuff, and this is from the cube demo from Sokol. So it just makes a cube manually, it just hard-coded a cube here. So these are the vertices of the cube, these are the indices, and then it loads a texture and stuff and sets up a pipeline for which has also the sort of layout for a shader, where to find things in the shader that is needed. And then there's a frame procedure here that is run once per frame, and it sort of does the updating of the state here, and then it does the rendering here. It also frees the temp allocator. So you can use the temp allocator to make temporary strings to put on the screen and stuff. I said 4 procedures, there's actually maybe 5 interesting ones. There's game event here. Here you can check for key presses and mouse stuff and touch events and stuff. I currently just use it to check for F6, which is the force reset thingy, but you can just use this for the input of your game. And game cleanup is for when the game shuts down, or when this hard reset of the game happens. So in here it shuts down the Sokol graphic stuff, and it also frees the global memory blob. Now there is a shader as well up here, like I said. Like here it sets up some layout for the shader, and it tells through this bind thing here which texture you should put on the cube, which is sort of has things to do with the shader as well. And the shader itself that is used in this case, you find in here. There is a shader.glsl file here. This is a sort of Sokol style shader that has both the vertex shader here and the fragment shader, and it has some extra stuff up here that is sort of unique to Odin, the package and some import stuff. And the reason this stuff is here, because it might seem weird that why would this be in the shader, is that Sokol comes with its own shader compiler. Sokol actually never loads this GLSL file. I have this gen__shader.odin here, and this one has the source code, the bytes for the HLSL and the fragment shader, and it tells it how things are mapped up in there. And this is generated, or it's compiled and generates this file using the Sokol shadec. That's the stuff that's here in this folder here we have for the different platforms. We're using the Windows one here. So this program takes one of those GLSL files with these custom annotations here and produces this Odin file. And this Odin file just goes as part of your program and contains both the compiled shader code, but it also contains like where are the different attributes of the in the shaders and the uniforms and the textures and the samplers and stuff like that. So it sort of, then you get sort of a native, you have this done for you before you even compile, and you have in Odin, you can sort of reason about where things are in the shader, which is what's happening here. We have img text. This is this thing here. It says which texture in the shader, and it also down here talks about the different attributes like the position, color, and text code, which is these things here. The build script will look through the source folder for GLSL files, and it will invoke the shader, the Sokol shader compiler on them, and output this gen file next to it, so it's all done for you. We saw the release build just now. The release build is much simpler than the hot reload stuff. If we look at what main release does, the main release file, it sets up Sokol like before. It gets the default description with the width and the height and the window title, and then it runs it, but there is none of that hot reload stuff in here. This is just a pure sort of wrapper that just calls into the game code. So if we see here, for example, on the frame, you just say game.gameFrame, and there's no DLL or anything here. What happens here is, if we look at the top, it just import game ... So it just goes up one folder and imports this as a package. So instead of using a DLL for this, it just has this Odin code in here as a package, and it uses that directly. So the release one is just a single application with no extra DLL that just calls into that just imports the game as a separate package and calls into that. And yeah, there's not much to it really compared to the hot reload code. It does the same Sokol setup, but none of the hot reload stuff. So let's finish off by talking about the web build support in this template. If we look at the GitHub page, there is a link here where it says the requirements down here. You need the Odin compiler, and it must be in the path, and you need Python for the build script, and then you need mscripten for the web build support. So you can click this mscripten link here to go there and download the mscripten and put it somewhere on your computer. In general, what you would do here is you go to downloads on the mscripten website, and then you follow the stuff here, installation instruction using EMSDK. So you do this stuff, and then you do this stuff, and then you're done. So when you have downloaded and installed mscripten and all that, then you need to rerun this compile Sokol thingy so that it can compile the WebAssembly libraries that we need in order to be able to make the web build. So if you run build.py -compile Sokol, and then you do -emsdk-path, and here we say where we put the emscripten stuff. So I put it in sdk/emsdk. Maybe you can skip this on some computers where EMCC is already in your path. There's also a little batch script inside the emscripten install called like emsdk_env that you can run that adds it to the path of the current command prompt and stuff. But here I'm just explicitly specifying it. So if we rerun this, first it compiles the C libraries again. And this stuff here, now we see that it says wasmgl. Now it's compiling the WebAssembly stuff. So it's finished doing that. Now we can make a web build of our game. So if we do build.py-web and press enter, then it says building shaders. Oh yeah, it couldn't find EMCC. So you once again need to do emsdk because it needs that to build the game as well. Then I had a typo here, emsdk-path, So build.py-web.emsdk-path like that. And now it says it built the shaders, it built the game object, and then it says something about building application. So if we go into build-/web and look what's in this folder, we see that we have sort of some files in here. We have an index.html file and stuff. We can't open this index.html file right away because of something called coarse errors. Essentially, it wants it to come from a web server. It doesn't want you to open random HTML files that open other files on your computer. So we can run python-m http.server. This will start a little web server that serves the thing in this folder so that you can just go to that address in your web browser and play your game. So python-m http.server, and then it says serving HTTP on port 8000. So then you can open your web browser, go to localhost, which is your local computer, and 8000 like this, and then you see you have your little web game running here. This one does not have any hot reloading or anything. It's just for doing the sort of release build of your web game. I recommend debugging your game whenever possible with the hot reload or the native version of the game. If you have a web-only bug, then I recommend that you compile with -debug to generate some extra debug info, and that you also check the console, the web developer console inside Google Chrome. Here I'm running in Firefox. I've noticed that it gives a bit better error messages in Chrome. And then we can finish off here by just looking at what the web version actually does. So there is a main web file here that contains an sort of like the other ones. There's a main web.odin file here, and it looks a bit similar to the release main release file. Some stuff it does differently. It uses a different allocator, uses the emscripten allocator here, which is able to allocate memory in a way that emscripten exposes. But the important here is also that inside the web folder down here is some extra stuff for the web build, and there's a template file here, index.template. This is what's used to create. So if we look in the build folder here, there's a index.html file. This file is based on the index template here, and this file it's just a simple website really that has a little canvas here, and it pulls in the Odin JavaScript environment, which is necessary for using code that uses the JS_wasm Odin build target. And then this also uses emscripten. So when emscripten runs, what happens is that when emscripten wants to sort of start up the WebAssembly stuff, it will call this procedure here. And in here, we actually load the index wasm stuff. And we also tell it that when it has finished loading, we want to run the _start procedure here. And this is actually exposed to call the main proc inside our program. So we have the main web thing here. This proc here will be called by this happening here. And this will set up Sokol, and Sokol internally knows that it is running in Emscript, and so it will do some magic stuff that make sure that it's not like blocking the whole web browser. It will just, whenever the web browser wants to re-render, it will sort of call into the frame procedures and stuff. Okay, that's it for this video. Thank you so much for watching. Thank you to my patrons. If you want to become a patron, there's a link to that in the description. I have also written a book about the Odin programming language. There's a link to that in the description. And I have a game jam upcoming called the Odin 7-Day Jam, the 8th of March 2025. You might be watching this after that time, but if you aren't, then maybe you can join the game jam. Maybe you can make something in Sokol using this template. I also have a Raylib template, excellent if you want to make a more simple 2D game, for example. And yeah, I will see you next time. And thank you so much for watching, and happy programming. Bye 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 bye.